In this session, we'll be doing a hands-on demonstration of running a Nextflow pipeline, and we're going to process the same input data that you previously used for your Data2 module. So it'll be the dog microbiome paired Illumina FASTQ files, and we're going to use this GitHub pipeline, which is the one that we use at our own institution to analyze our data. And I just want to give you a brief kind of orientation of what a Nextflow pipeline looks like on a GitHub repository. So typically we'll have a main.nf script file, and that is your main Nextflow script file. We'll have a look at that in a moment. And then we've got the nextflow.config, which is where we have all our configuration settings that are independent of cluster settings. And then in our conf folder, we add all other config settings that are cluster specific. So for instance, we've got a Elifu config for the Elifu cluster. We've got a ICTS HPC config for that cluster at UCT. And if you would like to set this up on your own cluster, then you define your own config file. So for instance, if we look at this file, it will specify the executor. In this instance, it's Slurm, the queue, and all the settings that are specific to your cluster. So you could use this file as a template and just modify it as you need it. It also specifies the Docker or Singularity containers that you use, and where that is to be found either online. So here we've got online images that get pulled, or it could be stored locally on your cluster. And so for each Nextflow process, we would specify the software container to be used. If we go back to the nextflow.config, so that is a config that you'll find in every Nextflow pipeline, and there we rather put all our parameters that are independent of our cluster setup. So don't worry about the details. All I want to show you is that you would have your default parameters here. So for instance, for our Data2 pipeline, we want trimming and filtering parameters. So first we're going to do QC on the reads and trim those reads. So we've set certain default parameters here that the user can easily change depending on their reads. And then you can also, for instance, set your reference database, whether you're using silver or green genes or whatever. And then here in the profiles section, that allows the user to very easily from the command line specify the user profile or the cluster profile that they want to use. So you can switch between different environments. So we'll be using the training profile, and there you'll find the training.config file that has been set up specifically for the cluster that we are using. Then if we go back and look at the main script file, so that's where we're actually going to code what our processes are. We can first, a commented section in Nextflow looks like this. So anything after or between those is not actual code, that's just for you. And then you can define a help message that gets printed to the user, and that tells the user how to use this pipeline, an example of running that Nextflow command on your pipeline, and then you'll see you can specify command line flags with a double dash. So for instance, we made a parameter called reads, where you specify your raw input data. Trim for specifies trimming for your forward reads and your reverse reads. And reference here specifies your taxonomic database that you're going to use for annotation. Another option, if you don't use command line flags, is to specify your own config file. So in that case, you'll use the built-in Nextflow parameter C. So you'll see this has a single dash, whereas parameters that we define specifically for this pipeline has a double dash. And here the user can specify their own config file. We're going to be using this top method, however. So this section is just the user help file that will get printed out, that shows you exactly what to specify for each one of those flags and what is available. And then we get to the actual coding part. So firstly, we set up configurable variables. So we're not going to go into detail here. You can look at this at a later point if you're interested. But what I really want to show you is just an example of what a process looks like. So our first step in this pipeline is going to be filtering and trimming, and we're going to run this as one job per sample. So this will run in parallel on the cluster, and so this pair ID will specify our specific sample ID, and we're going to give it a directory to publish our reads. And previously we discussed the input and output blocks. So from your command line input where you specified your FASTQ reads, this will get fed into this statement here, and this process will then get executed one job for every sample. We have an output file, and here in this script block, which is denoted by the 3 inverted commas, that is our actual coding. So in this instance, we're using a program called FastQC, and this will actually do the quality control on our raw samples. And over here, we actually get the filtering and trimming. So the same raw reads also go to this process, and the parameters that we specified on the command line for how we want to trim our reads are then picked up here in this trim for and trim rev parameters. In this script block, you can actually see that we use R script, and we're loading our Dada2 package just like you guys would have in your previous session. We're using the same functions. So within this script block, you can use scripts that you have that are existing and just modify them according to your parameters of input, so that you can have multiple samples processed in parallel. So now we can actually get started and try to run this Dada2 Nextflow pipeline. So you'll find instructions on the Vuda website that'll help you log on to the cluster, but I've also summarized it here. So you're going to log on with your username. So you would just substitute your own username here with SSH, and then you're going to start an interactive job from a worker node. So Nextflow, we don't want to launch from the head node because it uses a lot of memory to run Java. And so we rather start an interactive job from a worker node and then launch our pipeline from there. So to start an interactive job, you can use the srun command, and you'll use one node, one task. So you can literally just copy and paste this line over here. And then we're going to pull the Nextflow pipeline from GitHub, the one that we just had a look at. So first you can navigate to your home directory, just make sure you're there, and then we're going to use the git clone command to clone this into your home directory. So that'll grab all that code and pull it into your home directory. After that, we're going to change directory to the actual pipeline folder where our scripts are, and from there we can launch the Nextflow pipeline. So if you want to try follow along, the first thing I'm going to do is SSH onto the cluster with my own username. So now you can see the slurm_login, and then we're going to start an interactive job with the srun command. So if we just copy and paste that quickly, Now you can see you're on a worker node, so from there we can actually launch Nextflow. So the next thing we want to do is make sure we're in our home directory, and then we're going to clone this Data2 pipeline of ours. And so now it says, for me, fatal destination path already exists and it's not an empty directory. This is because I've already cloned this pipeline previously. So if I look what's in my folder, I can see there I have the pipeline. So for you guys, it should actually pull the pipeline and make that folder that says 16S RDNA Data2 pipeline. And so now we can change directory with cd into that folder, do an ls, and we can see now we have all the files that we had on our GitHub repository. We've got the conf folder that has our config files, we've got our nextflow.config, and we've got our main.nf. So now we're ready to specify our parameters as command line flags and try and run this pipeline. So if we just have another look at the basic usage of this pipeline, you can see there are mandatory arguments. So those are our input reads, and then you have to specify your trim forward and trim reverse. You have to specify your taxonomic annotation database, and you have to specify your profile. For the rest, we're not going to go into too much detail here, but there are several additional parameters that you can use at a later stage. So now we can go ahead and try and launch the Nextflow Run from our interactive session, and we use the command Nextflow Run, and then we specify the main.nf file. We're going to use the training profile, which specifies the cluster settings. So that is a built-in Nextflow command because you only see one dash. And then our pipeline specific parameters are our reads. So those are our fastq.gz files. And you'll see here we have the wildcard, and then we give it a pattern. So all the files end in _r, and then either 1 or 2, depending on it, if it's a forward or a reverse read. And Nextflow will then be able to extract samples from that pattern, and so whatever is before the underscore will be your sample names. So that is also really handy for pulling your samples together and actually using those names downstream. Then we've got our trimming parameters, forward and reverse, and we're just going to leave them as 24 and 25 for this demonstration. And then we're going to use the Silver database for our reference and species assignment. Our output folder is specified as out, so that'll be created in our home folder. And let's see if we can get this running. So if you copy and paste this command on the terminal, so we are on a worker node, and we're in the 16S RDNA Data2 pipeline folder. Then that should get us going. So you'll see Nextflow starts, and it starts running all the processes, and it tells you which are submitted and how many are submitted. So in this case, we're only testing 4 samples, so that's why we have 3 or 4 here, and it's currently running fastqc, and at the same time it's running filter and trim, because both those processes accept raw reads, so they can be run concurrently. And you'll see we're using the config profile training. So this will run and it'll give you the progress here. So we'll just give that a chance to run and then skip to the end.